welcome back to the Explainer. If you're a developer who is absolutely sick of wrestling with UI layouts, you are in exactly the right place. Today, we're diving deep into the B4XDaisyPageScroll component. We're going to look at how to finally ditch that tedious pixel math and start building fluid, dynamic screens with, honestly, zero headache. Let's just address the elephant in the room real quick. Are you still writing manual ScrollView math? Because man, we all know the absolute pain of building UIs without a native CSS flow. Keeping track of vertical Y coordinates, manually tweaking spacing, and having to recalculate your entire ScrollView height just because you added a single text field, it's the worst. You just end up with walls of boilerplate code cluttering up your project. So here's our game plan for today. First up, ditching that ScrollView boilerplate. Second, we'll meet our new best friend, the B4XDaisyPageScroll. Third, we'll break down the Nav Scroll Dock layout. Fourth, the magic of automated sizing. And finally, stacking those form UI elements. All right, let's jump straight into part one, ditching ScrollView boilerplate and comparing the old way versus the new way. Look, the old way of building these scrollable pages meant you were literally calculating exact pixel heights for every single view you dragged onto the screen. Tweak the padding on one button and boom, you're recalculating the math for everything below it. It's exhausting. But the new paradigm, it changes everything. Since B4X doesn't have CSS flow by default, we're shifting to a much smarter system. Think of it like stacking Lego blocks. You just drop elements in sequentially using a simple incrementing Y coordinate. Place a block, the system updates the coordinate, and you're instantly ready for the next piece. Which brings us to section 2, meet B4XDaisyPageScroll, the hero component of this whole setup. Okay, so what actually is this thing? Basically, B4XDaisyPageScroll is a highly reusable page container custom view. Under the hood, it perfectly encapsulates a scroll view and a transparent host panel into one super neat little package. Its entire reason for existing is just to centralize all that nasty boilerplate code. It manages the resizing for you and automatically calculates those scroll heights based entirely on whatever components you decide to throw inside it. When you pull this up in the Visual Designer, you've got 4 main properties driving the magic here. First up, page padding. That gives you your nice uniform content padding right off the page edges. Then there's YGap, which totally handles the vertical spacing between your elements so your UI doesn't look all squished together. AutoFitHeight is the real game changer. Flip that toggle and the system automatically resizes the scroll panel to fit whatever you drop in. And obviously, you've got background color, which you can set to whatever you want or just leave it completely transparent. Moving right along to section 3, the Nav Scroll Dock layout and its 3 fixed zones. This layout pattern brilliantly divides your full screen up into 3 distinct zones. Step 1 is your pinned nav bar right up at the top. Step 3 is your pinned dock at the very bottom. Now, both of these are anchored directly to the main root canvas, meaning they are completely fixed. They are never going to scroll. Step 2, right in the middle, is our B4XDaisyPageScroll. It's dynamically inset, so its top starts exactly beneath the nav bar and its bottom ends right above the dock. It essentially creates this perfect dynamic scrolling canvas right in the center of your screen. And this brilliantly illustrates exactly what I'm talking about. Over on the left, you're looking at the top of that inset middle zone, loaded up with text inputs and drop-downs, sitting super cleanly beneath that fixed purple top bar. Now, as the user actually swipes down, which you see on the right, stuff like toggles, the range slider, those star ratings, they all scroll up perfectly. And notice how they just vanish behind the top bar without ever overlapping that bottom dock. To pull off that visual perfection, the code relies on a really specific absolute positioning trick. Think of it literally like taking a piece of paper and dropping it right on top of a pile. By calling bring to front on the nav bar, it lifts that view above literally everything else on the screen. That completely guarantees your scrolling form content in the middle layer slides flawlessly underneath your fixed top bar. Pretty slick, right? All right, section 4. Let's look at the automated sizing magic and how it actually works under the hood. You might be wondering, how does this container actually know how tall it's supposed to be? Well, it uses a built-in subroutine called AutoFit. When you trigger AutoFit, it rapidly loops through every single child view inside that host panel. It checks the top position, adds the element's height, and calculates the absolute highest bottom coordinate among all those elements. Once it finds that maximum bottom value, it just tacks on your designer page padding for some breathing room and updates the ScrollView's height to match it perfectly. It is flawless automation. Now, to make sure all of this survives a screen rotation, the layout makes clever use of class_globals. You can think of class_globals as your page's inventory box. Any variable you declare in there is going to stick around as long as the page is in memory. We safely stash our main parent panel, the root, right inside this box. That way, our layout builders can constantly reference its exact dimensions and instantly react to any orientation changes. So let's say that screen change does happen. Maybe the user flips their phone into landscape mode. Boom, the B4XPage_resize event fires off automatically. The code instantly grabs the new screen width and stretches out the nav bar. Next, it re-anchors the bottom dock by taking the new root height, subtracting the dock's height, and pinning it right back to the bottom. Finally, our page scroll container recalculates itself to completely fill that newly shaped middle gap. Nothing gets clipped, and the whole UI stays beautifully responsive. Which brings us to our final part. Section 5, Stacking Form UI Elements and the Final Build. Whenever you initialize your page, you're going to run a build form subroutine. And this is exactly where that whole Lego block concept actually comes to life. You start off by declaring a vertical coordinate variable, let's just call it y, which usually kicks off at whatever your page padding value is. Then, as you drop in an email field, a password box, or a submit button, you just increment that y coordinate by the height of the block you just snapped into place. But honestly, it gets even better because the B4XDaisyPageScroll component gives you helper subroutines to essentially do this for you. Methods like add section title or add divider, they don't just draw the UI, they actually return the exact next y coordinate right back to you. Add in the getUsableWidth helper, which instantly gives you the total screen width minus your paddings, and you literally never have to do that manual addition or subtraction in your head ever again. You just feed the return values right into your next element. Put all these Lego pieces together, and you get something like this. A super clean, incredibly modern-looking screen. Look at how uniform the padding is, how logically the elements stack. The title and the inputs have perfect breathing room. And the absolute best part? There is zero visible boilerplate code cluttering up your workspace to manage it. The page scroll handles all the tedious heavy lifting, which lets you focus 100% on making things look great, like that really sharp purple login button right there. So I've got to ask, are you ready to finally stop calculating pixels and actually start building features? By dropping B4XDaisyPageScroll and the Nav Scroll Dock layout into your projects, you're stripping out all that friction, completely protecting your screens from weird rotation clipping, and making your codebase infinitely cleaner to read. Seriously, dive into this code and try the Lego block approach on your very next build. It's a total game changer. Thanks for hanging out with me on this explainer, and hey, happy coding!